Assalamualaikum warahmatullahi wabarakatuh. I'm Hasif bin Zulkifli from Universiti Teknologi Malaysia Melaka, and I'm presenting on behalf of my team member, which is Mohd Fauzi Mamat, Mohd Syafiq Izwan bin Akhir, Joseph Sahaya Anand, Mohd Zaimi Zainal Abidin, Mohd Safwan Ismail, Lailatul Harina Paijan, Mohd Hadley Abu Bakar, Nur Farazila Abdul Yusuf, Mohd Rafi Omar, Mohd Idain Fahmi Rosli, and Atira Sofian for 34th International Invention, Innovation and Technology Exhibition Malaysia ITEX 2023. And our project is SALUTAN SEMBUH or self-healing coating. So for the introduction of our project, is most metals suffer corrosion, and corrosion can lead to loss of life and economy. Furthermore, it is inevitable and ongoing but controllable, and controlling corrosion can make metal have a longer lifespan. Next is a problem statement for our project. Many efforts be made to prevent huge loss in corrosion of metal in automotive, marine, oil and gas, and aerospace industries such as polymer coating and corrosion protection. While in the service, the polymer coating tends to mechanically damage such as a microcrack, and the corrosive species can penetrate to metal surface. The corrosion process cannot be avoided, and it need to design and produce coating which have the potential to repair the damage and thereby retain the protective properties. As you can see on the screen, we have at the first layer we have a seawater, and then we have the self-healing coating, and at the bottom we have a metal surface or low carbon steel substrate. First, we make a scratch on the sample that have a self-healing coating, and the penetration process will occur, and then self-healing agent come to cover the surface, and microcapsule will swelling, and then it will be penetration until all the open surface have been covered. And synthesis of the microcapsule. First, we have 160 ml deionized water, and then we add the 5 gram urea and still at 700 rpm, and then we add the mixture of the 0.5 gram ammonium chloride and 0.5 gram isosonol, stir in 50 or 20 minutes. After that, we add the emulsion of pH adjusted 2 or 3 drop by adding 10% weight of hydrochloric acid. Then we add the 2 or 3 drop of ethanol. Next, we mix in 15 minutes under agitation. After that, we put a 60 ml linseed oil slowly to form the emulsion. We wait for 15 minutes for the agitation. After that, we put 12.67 gram formaldehyde. After that, we stir for 3 or 4 hours at 55 degrees Celsius at 700 rpm. After stirring process have been done, we do for the next process, which is filtration. After that, wash with the acetone. After we have washed with the acetone, we will get the linseed oil microcapsule. And after we got the linseed oil microcapsule, we will keep in the vacuum oven at 35 degrees Celsius for 2 days to get the final linseed oil microcapsule. Next is the microcapsule healing agent. As you can see in the screen, we use a scanning electron microscope or SEM micrograph to reveal the microcapsule, and the result that we got, the microcapsule were spherical particles with a diameter of between 200 micrometer. Then for the fabrication process, we have epoxy paint mixed with 7.5% of microcapsule, and then we get the self-healing coating. So the novelty of our project is first we have a green material, which is epoxy coating incorporated with a green microcapsule, and then we have a coating performance, which is it increased the lifetime of the polymeric coating, and then for the corrosion behavior, it reduced the corrosion rate and failure issues. Next, for the self-healing performance, as you can see on the screen, we have 3 samples, which is first is epoxy coating, self-healing coating, and then the result for the self-healing coating. Here you can see the 2 samples, which is epoxy coating and also the self-healing coating, which is the self-healing coating. The surface area that damaged has been covered fully compared to the epoxy coating, and then the amount of ferrum in the sample that coat with the epoxy coating is higher because the scratch area do not be covered or protected by the healing agent when the corrosion agents occurs. And then we have the difference in the weight percent of the ferrum for the epoxy coating and also for the self-healing coating, which is the self-healing coating show the percent of the ferrum is much lower compared to the epoxy coating. For the weight loss measurement, we can see the graph that show three type of the coating, which is the black one is uncoated, the red is coating with the epoxy, and the blue one is the self-healing coating. So the graph of weight loss in the 3.5 weight percent sodium chloride solution shows that the self-healing coating shows the great performance, which is it has the lower weight loss. Then without the healing agent for the epoxy coating and uncoated shows the higher weight loss due to unprotected on the metal substrate. For the corrosion rate measurement, so the graph of the corrosion rate for the sample immersed in 3.5 weight percent sodium chloride during the exposure times in 7, 14, 21, 28 and 35 days shows that the great performance of the self-healing coating. And then without the healing agent for the epoxy coating and uncoated shows the higher corrosion rate compared to the self-healing coating itself. For the infographic self-healing mechanism, first we have a raw material, which is linseed oil, and then we do the process of the microcapsule. And after that, we prepare the three sample, which is uncoated sample, epoxy coating sample, and then the self-healing coating sample, and then we immerse in the 3.5 weight percent of sodium chloride. After that, we do the visual inspection to see the scratch is closed for the self-healing coating. Then after that, we do the energy dispersive X-ray spectrum or ADX to check the presence of the ferrum on the sample surface. And after that, we do the weight loss and corrosion rate measurement to see the performance of these three samples. And the potential commercialization for our project is it will benefit the pipelines, structures, oil and gas equipment, on or offshore structure, and also a metal structure. Overall, we can conclude that the self-healing coating has the potential to repair or restore damage to the coating to avoid further corrosion. Next, the performance of a microcapsule is excellent because the microcapsule successfully healed the scrap area even though it was immersed in the marine environment. The last one is the newly modified surfaces coating will reduce the manufacturing cost and increase the lifetime for the coating. Letter of intent, LOI or MOU, here you can see in the screen. Here attached with the copyright of our project, self-healing coating. And also the journal publication for self-healing coating. Last but not least, the innovation competition that we have participated under the project title self-healing coating. And as you can see on the screen, here's some achievement that we got from the competition. It's all from us. Thank you.